welcome back to our third class of logarithm, and I'm going to look at anti-logarithm. And the anti-logarithm is basically the reverse process of finding the logarithm of a number. So when we now have the logarithm of a number, you can be able to go back to know which number did give us that logarithm. That process is the one that we talk about today, anti-logarithm. And to demonstrate this, I would like us to do a few examples here so that you can be able to have an understanding of the same. And we are going to use table on the same. Can I have a question like this? Find the number whose logarithm is. Find the number whose logarithm is part 1. We can have 0.1438. 0.1438. So when the number is like that, we know if this is the logarithm of a number, then looking at it, it is the same as now the 10 power 0.1438. Which number did it give us this? So we are going to now look at the table. You're going to use the tables of antilog. And when I look at the table of antilog, I'm going to see they are starting from point something. So here, we just need the decimal part from the tables of antilog. So we're going to look for 0.143. Go to look for 0.143. So 0.143, using that table, we are going to get 1.390. So 1.390, that is 0.143. Then we go to the addition part. We are going to add what corresponds to the 8. Go to that column, and we have 2. And that 2 we usually add to the far end there. So you have 2, 9, 3, 1. So the log of when the log is 0.1438, the number that is going to give us that log is 1.392. So that is now the number. That is log. That is the number that, of course, gave us that. So that process of now moving from the log table, from the logarithm to the number is the antilog. Let's have another example. Example 2. We have 2.892. 2.892. So in this case, we have using our table, we only need the decimal part. So this one we can write it the way before, so that for us to get the 2.892, we had 10 power, the decimal part, 0.892. Then we were multiplied by 10 power positive 2. We multiplied by 10 power 2. That is why we came from, for us to get the logarithm being 2.892. So the mantissa part, of course, is 0.892, the decimal part, and then this whole number power 2 there, it is our now the characteristics. So now we want to get the number that gives us 0.892. So that is now the antilog, and I'm going to read 0.892, that is direct, is going to be 7.798. 7.798. 7.798. That is the antilog of 0.892. Then you are multiplied by 10 power 2. So of course we can leave it like that, or we just open times 10 power 2. We go 2 steps forward, 1, 2. We get 779.8. So when the log is 2.892, then the number that gives us that log, or the antilog of this one, is 779. 0.8. Another question, part C. We look for the case where you have a bar number, like now. Let's have this question. Bar 3.4052. Bar 3.4052. So for us to get to this number, bar 3.4052, we came from where now? This is a logarithm, so it was 10 to power this whole number, decimal part, 0.4052 times 10 to power negative 3. The bar 3 there, it is 10 power minus 3. Now, so you did the answer of 0.4052. 0.405, that's the first part to read. 0.405, we get 2.541. 2.541. That is the answer of 0.405. Then we go to the additional part. We look for what corresponds to 2. Look at that. 2 is going to correspond with 1. This one we add to the far end there. We add there. So you get 1 plus 1 is 2. And 4, 5, 2.5, 4. Then we had times 10 power negative 3. So times 10 power negative 3, we go backward 3 steps. So 1, 2, 3. So that number gets 0.00254. So when the log is by 3.4052, the number that corresponds to that log is 0.002542. That's how you get the antilog of number using either using the tables. And I want us to look at something else very related to that. That is addition and subtraction of the bar numbers. Can be told to calculate you have bar 2.37. We add 1.20. So these are bar numbers, we are adding them. So when you're adding, so 7 plus 0 is 7, 3 plus 2 is 5, then bar 2 plus 1, that is the same as minus 2 plus 1, this is going to give us minus 1. So here good rate bar 1. So that's how you can be able to perform that operation. Another question. We have bar 7.12. Bar 7.12. Then we subtract bar 5.54. Subtract bar 5.54. So we are subtracting. So whenever you're subtracting, of course, you have 2 minus 4. 2 minus 4, of course, you need to borrow 1 from here. Go to the remaining is 0. Then you have 12. 12 minus 4 is 8. Now this is 0. 0 minus 5 is not possible. We borrow 1 from minus 7 or bar 7. So when you borrow 1 from minus 7, we subtract 1, we're going to be having minus 8. So we're going to be left here with minus 8. And this is going to be now 1. Then 10, of course, is going to be 5. Point now minus 8 or bar 8 minus 5 bar 8 minus 8 minus 5 minus 4 minus is plus, so you have minus 8 plus 5, and this is going to give us minus 3. So here good rate bar 3. So whenever you are doing the subtraction, you have to be very keen on those signs. And something that we need to be keen here is that when you are borrowing a negative number, that negative number is going to reduce. So it is going to be minus 8. And of course, you're going to have it like that. Let's do 2 more, and then we call it a class. part C, and the same by 3.79, then we subtract by 2.24, so we are subtracting this, and of course we just do the normal subtraction. 9 minus 4 get 5, 7 minus 2 get also 5. Then we have minus 3, minus 2, minus 3, minus 2. So minus 4 by minus is plus, so minus 3 plus 2, so you get minus 1. So here we write by 1.55. Lastly, we have 5.27 minus by 2.73. So we are subtracting this. So you have 7 minus 3, you get 2. Then you have 2 minus 7, not possible. You borrow 1 from 5, you get remain with 4. So you have now 12 minus 7, you get 5. Then 4 minus 2. 4 minus 2. 4 minus 2 going to be 4 plus 2, you get 6. So there you get yourself as 6.52. And that's mark the end of our session. Just to encourage you to find some more questions, you practice, and of course we say that practice makes perfect. Otherwise, thank you very much for your time.